that we are looking at elimination, we have to figure out how to manipulate an equation to make it fit the elimination process. It isn't just magically going to look like everything is nice and neat with the numbers. So for example, let's say we are given 5x plus 7y equals 3. And 2x plus 3y equals 1. So if we go down our list, are we going to want to solve this one by graphing? No. Not really. We'd have to solve both of them for y. We don't really have a graph. We're going to get weird numbers. Yeah, don't want to go that route. How about substitution?
You could.
I mean, we could, right? We could solve one of them for y. Hi, do you want to substitute an equation with fractions?
Nope.
Not really probably on the majority of our lists. Okay, so then we move to elimination. Elimination, we said we want a variable that has a matching coefficient. So do either of those x's have the same number in front?
No.
No. Do the y's have the same number in front?
No.
Oh. So are we out of luck?
No. Multiply.
Right, so it sounds like some of you have actually seen this before. In the math world, we've talked about this before. As long as we multiply each side, I mean, we could add, we could subtract, we could divide, we could multiply. As long as whatever we are doing on one side of the equation, we do on the other side of the equation, we are creating a new equivalent equation. What does it mean if it's an equivalent equation?
The same.
What do we mean by the same? Because it's not identical.
They equal the same.
What do we mean they equal the same?
If you solved it, they would equal the same.
If we solved it, they would have the same value, right? So that's when we talked about solving for y and them having the same look. Right? They are holding the same value. Me having a $10 bill and someone else having two $5 bills is equivalent. They look very different. We have different amounts of paper, but we are holding the same amount of value. So our objective is going to be to manipulate the equations to make them have matching coefficients. So here you just kind of have to use your brain. We're going to go through and we're going to start thinking. Is there anything I could multiply 2 by to turn it into a 5?
2.5.
I mean a decimal, ugh. Don't really want to do that. Anything I could multiply 3 by to turn it into a 7?
2.5.
So don't want to do we don't want to do a weird fraction or decimal.
The thing where you, like the fractions were like you multiply or like 2 by 5 and then 5 by 2.
Right, so instead of multiplying one of them, let's see. Is there something I could multiply, even if it's 2 different numbers, and get these to become the same thing?
Yes.
2 and 5.
So I could turn a 2 and a 5, both of them could turn into a 10. Right, I can't make a 5 become a 7 by multiplying by an integer value, right? But I could choose to multiply this top equation by 2 and this bottom equation by 5. Now, the problem with systems is that your work could look nothing like your neighbor's work and you could get the exact same answer. Because what happens if Mallory's looking at the problem and she's like, oh, geez, I didn't even see that. I was going to multiply this by a 3 and this by a 7. Would that be okay?
Yeah.
What happened if someone said, oh, man, duh, what was I thinking? I was going to multiply this by a 4 and this by a 10. Would that work?
Yep.
Yes. There are so many different options. The goal is just to make them turn into the same number. Now, before we start multiplying, there were 2 objectives. We wanted them to have the same coefficient, but we wanted them to have the opposite sign. Why was it important that they had the opposite sign?
So 0 out.
Is it right? We wanted them to add up to 0. So if we check, is this x positive or negative?
Positive.
And is this x positive or negative?
Positive.
So are these currently opposite signs?
Nope.
No. So remember how we said on Friday it was like multiplying a -1 through? Let's not do that as a completely separate step. Let's just go ahead and put that negative onto the number that we're already multiplying by. And then it doesn't make any additional work, and it takes care of the fact that we don't have to subtract, which we're trying to avoid anyways. Okay, my students typically are totally fine with elimination and figuring out what to multiply by. They are really bad at multiplying all the way through. The most common mistake that I see has nothing to do with elimination, and it just has to do with multiplication. So just make sure you're careful with your math. So we're going to multiply this 2 all the way through. So 2 times 5 is 10x. 2 times 7 is 14. All the way through, because whatever we do to one side of the equal sign, we have to do to the other. 2 times 3 is 6. Then we're going to do the bottom row. -5 times 2 is -10. -5 times 3 is -15. And -5 times 1 is -5. And now I have a system that looks nothing like the original problem, but because we made sure to use solid math rules that said if we multiply one side and the other, it holds the same value. This holds the same value as this system. It just looks completely different. Yes, sir?
So why can't you make that 5 a negative when you multiply the rest of it? Like 2x plus 3.
Why am I making it a negative, or why am I allowed to?
Yeah, why can't you? Why are you allowed to?
I could make this a -42 if I wanted to.
But then wouldn't the 2 also have to be negative? That you're multiplying
But it's
through?
equivalent, so.
No, you can choose to multiply by anything you want to, as long as you multiply all the way through and it hold the same value. So I could choose to multiply by pi. I could choose to multiply by the square root of 7. Is that going to be helpful?
No.
No. Right? So I can choose to multiply by anything. I'm just choosing to be very careful in doing it. As long as I multiply all of those pieces, it looks very different, but it creates the same value. Does that make sense? Does the answer? Okay. So now that we're here, we're going to ignore this. Now do we see somewhere that has matching coefficients?
Yes.
Yes. Which one?
The x.
We're going to focus here. What is the sign of the top x?
Positive.
And what is the sign of the bottom x?
The negative.
Which is exactly what we want to happen, right? That's why we put that negative through. So now we can just add these two equations. Ooh, don't want to do that. Try again. Okay, so what is a 10x plus a -10x? 0. They go away. What is a 14 plus a -15? -1. And what is a 6 plus a -5?
Positive.
+1. And do we know how to solve that?
Yes.
Yep, so we can divide by -1 to solve this. Okay, so my students at this point will say, Mrs. McKinney, do I really have to divide by a -1 there? Do I have to show that step? I mean, we're at the point that I would hope we know that that just turns into a -1. But it's going to be the same thing I consistently say. I cannot read your brain. So if I don't see the work, I can't give you partial points. All right, but there might be some places in here that you're like, do I really have to write that down? Well, no. Are we done?
No.
No, because the solution to a system is a what?
Or
X and Y value. So how are we going to find our X value?
plug it back.
Where do we want to plug it in?
Okay.
The original bottom equation.
I would go for the original bottom, but would it be okay if we plugged it in here? Yep. Could we plug it in here?
Yes.
Yep. Could we plug it in here?
Yes.
Yep. Right, I would choose this one because it's the smallest numbers. So instead of saying 3 times y, what am I going to say?
3 times
3 times -1, and what is 3 times -1?
-3.
And then we'll solve. How do we write this answer as an ordered pair?
2,
2, comma, negative 1.
2 comma negative 1. How do we feel about that one?
Good.
Very good. We'll get one more. 2x minus y equals 3. And 5x plus 2y equals 30. Okay, so if we're going to solve this by elimination, do we see anything that has a matching coefficient?
No.
No, so we're going to have to do some multiplying. Anybody have a place they'd want to multiply? We should all be able to say I have a place that I see something that I want to multiply, I would hope. This class just seems to only have our select who are willing to give forth their input. William, what would you like to multiply?
The top one by 2.
Top 1 by 2.
Yeah.
Anybody say, are we okay with the top 1 by 2? Would anybody have done something different? Here's the one thing that I can tell you. Okay, and it makes me sad every time that it happens. I'll have students who are going and they will multiply by 5 and then by negative 2. And they get halfway through and they're like, oh, it would have been so much easier to just multiply by 2, and they erase all their work and start over. Okay, it's not easier if you're already halfway through multiplying. Okay, there is no like goal of you're a winner if you choose a smaller number. Yes, sir.
Can you also just simply multiply 1 by 1 and then the other one by negative 1?
Right, right. Sometimes you're just going to be multiplying by a negative 1 if they already match. There's lots of different options. So don't feel like you have to do what your neighbor is doing. I would love it if my students all did the same thing. It would make my grading way easier in life, but that's just not how it works, so it's okay. So are we all okay with then saying this top 1 by 2? Do we want to multiply by 2, or do we want to multiply by negative 2?
Negative 2.
Pause.
2.
No, because it needs to be opposite.
It's already a negative.
So if this one is negative and this one is positive, are they already the opposite signs?
Yeah.
Yes.
So do we need to add a negative?
No.
No.
No. Right? So if they're already opposite signs, don't throw any negatives on there. So our top one we're going to rewrite as 4x minus 2y equals 6. What are we going to do with our bottom equation? It just stays the same, right? It's like multiplying by 1. Now, students will then say to me, Mrs. McKinney, do I have to rewrite this entire thing? Could I just put this one underneath it? Yes. Yeah, it's totally fine. Okay, I strongly encourage that you don't scribble over it and try and write a new number. I tend to see a lot of mistakes there just because students then don't read their own writing very well. Now are we good to add?
Yeah.
Yep. So 4x plus 5x is 9x. Negative 2y and 2y is 0. 6 and 30 is
36.
Are we done with x equals 4?
No.
No, what are we going to have to do?
Plug it in.
Plug it back in. Where do we want to plug it back in?
The bottom.
The bottom one.
This bottom one?
Yeah.
Yeah.
Doesn't
Oh,
have a
that's
negative.
weird.
Doesn't have a negative.
Yeah.
Yeah, but to undo a negative, you just use addition, which seems easier than undoing it with subtraction, but whatever.
I don't know. I just picked
That's
up.
okay. So 5 times 4 is
20.
20. Solve.
It's hard for me to mess up and not put a negative if I use a negative, so.
What's our answer as an ordered pair going to be?
4, 5.
To each their own. You can plug into whatever equation you would prefer. Do you get the idea of how this works? I mean, I could stand up here and do 100 of these, but